Hi, I am Godji. With me is Krishna. And we would like to thank you for joining us today. And we would like to go over a better understanding of Thor and Roxie configurations for the Containerized HPCC Systems Platform. Throughout this presentation, we will be using Terraform for our deployment. So what is Terraform? Terraform is an infrastructure as code tool provided by HashiCorp. What it does is that it codifies infrastructures such as compute, network, and storage. It automates and manages cloud resources. And it uses the HashiCorp configuration language to do that. So what is Thor? As you might already know, Thor is basically used to refine data. It is fault resilient, and it distributes file parts on multiple nodes or VMs. So here's an introduction of Thor configurations. Here we have a Thor list of dictionaries. So the first line is basically the name of the list. The second line, where it says name, is basically the name of the Thor cluster, and currently the name is Thor. And the third line is prefix. So the prefix is basically used for non-fully qualified logical file name. For instance, where you do not have a complete file name, where then the prefix would be added after the tilde, followed by the scope, and then the file name. On the fourth line, we have non-workers. Non-workers is basically how many workers in the cluster. So right now we have a two-way cluster. And the fifth line is max jobs, which is basically the maximum of jobs that can run on the cluster. And we have max graph. Max graph is the maximum number of graphs for the cluster. We have the max graph startup time, which is basically saying how long should the job wait for its turn. And currently it's at 600 seconds. Num workers per pod. This is self-explanatory. So it's basically the number of workers per pod, followed by the manager resources, which is the Thor manager. We have the number of CPU and memory. Next, we have worker resources, which are the worker pad resources, such as CPU and memory. And currently, our memory is 4 gigabytes. After that, we have worker memory. So as you can see, the worker memory is divided in two. The first one is query memory, and then followed by the third-party memory. So together, as a total, the query and the third-party memory should not exceed the worker resources memory. So currently we have worker resources to be 4 gigabytes of memory, and that the query and third-party should not exceed that 4 gigabytes. After that, we have the ECL agent resources, which is similar to worker resources, where we have the CPU and then followed by the memory. And last, we have egress. Egress is basically the network rules for the Tor component, where we say which endpoints or ports the component should be allowed to connect to. And on this slide, we have an example of a Tor configuration using Terraform. And Tor right now is a list of objects. The reason being is that you can duplicate that object inside the list to create another Tor cluster. So currently we have the this Tor cluster enabled. And as you can see, we have the same attributes that we went over in the previous slides. We have name, we have prefix, we have non-workers, we have keep jobs, max graphs, max graph startup time, non-workers per pad. We have manager resources, as we saw earlier. We have worker resources. We have worker memory. As you can see, the worker resources memory is 4 gigabytes, and the query and third party together do not exceed that 4 gigabyte of memory. And then we have the ACL agent resources, CPU and memory, and then we have the costs, which we didn't see earlier, but which is also part of the Tor configuration that is available. Next, we have a demo of the Tor configuration using Terraform. So here we have the same object we saw earlier on the previous slides. On the previous slide, and here we can run the Terraform apply command, which would deploy the Tor cluster. And if we go to ECL watch, we can see, if we go we can see the Tor. And if we come to the console, we can do a kubectl get namespaces to get the namespace of the Tor deployment, the HPCC deployment. And then once we have that, we can do a helm get values to get the Tor values that are currently being used for Tor. Here we go. As you can also see, these are the same attributes that we went over. This is our configuration for Tor. And on the next slide, we have another demo for ECL watch. If we go on ECL watch, and we can also see, see the Tor cluster. And if we go to the playground, we can quickly run a test on the Tor cluster to see how our configuration performs. Here we submit the job, it's compiling, and it is completed. So if we go, we can also go take a look at the work unit tab to see our job. Here's a typical work unit. We can also open that and view the output and the results. So basically, this is our tool working perfectly as intended. And if we want any modification on that cluster, we can always go back to our configuration and make that change and then do a Terraform apply again. This was an overview of Thor configuration for the containerized HPCC Systems Platform using Terraform. I hope this was helpful to you and helped you understand better how to configure Thor for the containerized HPCC Systems Platform. Next, we will go over Roxie, and for that, I will that will be Krishna, who will go over who will give you an overview of the Roxie configuration.
Thank you, Godji. Now let's take a look at the configuration for Roxie section of the HPCC. What is Roxie? Roxie, which basically stands for Rapid Online XML Inquiry Engine, is a data delivery engine used in the HPCC system to serve data quickly that can support thousands of requests per node per second. While Thor is configured to run one or two processes against very large amounts of data, Roxie is designed to return thousands of concurrent queries against that data. Now let's take a closer look at the Roxie config. Now, like Godji had mentioned for Thor, you have the similar sections for Roxie, right, where you have the name of the list, then you have the name of the first Roxie cluster in the list, where it is Roxie in this instance, then whether the Roxie is enabled or disabled, which is a Boolean value, and then the prefix. Then you have the services, which is which service port is Roxie running on. If you have used HPCC systems on-prem or on cloud, you would always use the 9876 port for the Roxie services. Then the listen queue, then the number of threads that are running, and then the visibility, whether Roxie is only visible locally or globally. Then you have the replicas, the number of replicas per channel. Then you have the number of channels. Then you have local agent, but the default value is false, which means you're running a multi-node cluster. Set local agent to true for a scalable cluster of single node Roxie servers, each implementing all channels locally. Then you'll see the trace level. The default value of the trace level is 1. You might want to adjust the trace level to get the information you need from the log files. Like if you're trying to find the transaction summary information when you run a query in Roxie, the minimum trace level you want to set is 3. Anything below 3, you'll not be able to see that information. So the more information you want in the logs, the higher the trace level needs to be. Then you have the total memory limit. Then you have the MTU payload. Set the MTU payload the maximum amount of data Roxie will put in a single packet. Then you have resources. Specifies the resources required by each agent pod. Like in this instance, you have the number of CPUs, the amount of memory. Then you have server replicas. The set server replicas to indicate a separate replica set of Roxie servers, which agent pods not acting as servers. Then if your server replica is set, then the resources required for the server pods can be configured separately from the agent pods. Here you see the server resources where you have set the CPU and the memory. Then you have set the CPU and the memory for the channel resources. Then you have the minimum startup time, which is basically how long to wait before initializing a startup probing for a pod. Then you have the maximum startup time, which is the maximum time to wait for startup to complete before failing the pod. Then you have the replicas. Then you have direct access planes. You can add direct access planes that Roxie will read from without copying the data to its default data plane. Then you have the LDAP user. Add system username for accessing files. Then you have the egress rules for the Roxie component. Now, the previous ones, these are the ones you usually see in when you look at the YAML file on the clusters. There are some additional values that you can set for a Roxie in the config. Right? Some of these we have already seen previously, like disabled, which should be configured as a Boolean value, the name, which is a string, right? Node selector, the num channels, which is a number, the prefix, a string, replicas, number, server replicas, which is also a number. So these are some of the values which you have seen in our previous slides, and we have gone through these ones. Then you have ACE pool size. You have act reset log period. Then all div files dynamic, blind logging, and blob cache mem, callback retries, callback timeouts, check file dates. I'm just going over some of the ones which most of you are familiar with, but there are a lot of other options that can be configured in the Roxie config file for a Terraform. Then you have copy resources, which is a Boolean. Then we have data files are lookup timeout, debug permitted. Then you have the default memory limit, which is down here. Then you have default SLA priority time limit. Then you have default SLA priority time warning. Then disk read buffer sizes. Then you have the egress rules, which we have seen earlier. Then you have the fast lane queue, a high timeout, ignore missing files in Roxie, index read chunk size, and you have lazy open, which is a Boolean value. You can set the lazy open to tell Roxie whether it is going to validate whether all the files are available at either start time or at runtime. That means when the Roxie starts, it will check to see if all the files are available. Or you can set it to say, we don't want Roxie to check when it starts, but when I'm running the query, it can go and validate if the files are there or not. Then you have leave cache mem. Then you have local files expire, local slave, log full queues. Then you have the max block sizes, memtrace levels, memtrace size limit, node cache mems, node cache preload, per channel flow limits. What we have done as part of moving to cloud is added a lot more flexibility for tracing and logging purposes. That way we can debug a lot of information from the logs. And we can specifically look at whether it's a memcache, UDP, or regular trace levels. We can separate those things. Then you have the ping intervals, then preload once data, pre-start slave threads, remote file expires, server threads. Then you have slave threads, SOAP trace levels, socket check intervals, then trace levels, which we have seen previously, where the default value is 1, and you can set at what level you want, depending on what kind of information you want from the log files. Then you have options now to trace remote files, trace memory limit, then trap too many active queries errors. Do you want to trap it or not, which is again a Boolean value. Then you have a lot of options for tracking or tracing the UDPs. You have UDP adjust thread priorities, the flow socket sizes, queue sizes, request to send acknowledgement back timeouts, resend timeouts, request to send timeouts, retry busy senders, send completed in data. Then you have the UDP trace levels, then UDP sniffer enable, use remote resources, use tree copy, you have the services, you have the topology servers, the channel resources settings, which we have seen previously of how the CPU and the memory setting for those. Now that we have all these options, if you look at all the options that you have available in here, there are about 145 different options that can be set to customize, collect the information you need, and debug the Roxie that you can set. Now you have all these options. How do you set them? One of the ways is create a Roxie TF vars file and set the values. Like we have seen previously, you can set the disabled, which is a Boolean value, to a true or false. Then the trace level, which is defined as a numeric value to 3. Right? Then you have the use remote resources, which is a Boolean. So it's either a true or false. Then you have the copy resources, again a Boolean value, so true or false. So one thing you want to do is be careful of using the correct values. So if you look at all these options that are available, which are in the variables file of the Terraform code, it will tell you whether it is a number, Boolean, or a string that you need to use. Depending on that, you can set those in roxie.tf vars file when you run Terraform apply or Terraform init commands. If you want to use the Roxie code by its roxie.tf vars file without passing it in, just specify the name as roxie.auto.tf vars file, and it will be picked up when you run Terraform apply. Now let's take a quick demo similar to what Godji had shown you for Thor. Similar to what we have done previously, first let's get the namespaces. In this instance, we are using the namespace that Godji had created. Now let's get the pods in that namespace. You see the Roxie pods that are running. Similar to what we have done with getting the values for the Thor, let's get the values for the Roxie section. These are all the options we have just seen, which can be used to configure the Roxie. Now, once you have set up the cluster and Roxie is running, you can go to the playground and select the Roxie as target, and you can publish your query. Now you can look at see the work unit and the output and look at the query that's been published on the Roxie pods that were set up using the Roxie configuration and Terraform's code. Thank you for your time, and please let us know if you have any questions. We'll be more than happy to answer. Thank you.
Thank you, Krishna. And thank you, everyone, for attending our session today. I hope that gives you a better understanding of Thor and Roxie configurations for the containerized HPCC Systems Platform. Thank you and have a good day.